Welcome back to part 2 of the epic story of humanity's exploration of Mars. In part 1 we followed the incredible race between the Soviet Union and the United States, as both nations fought to become the first to reach the Red Planet. Now the race enters an entirely new chapter. For the first time, humanity won't simply fly past Mars. It will attempt to land there, survive and answer one of the greatest scientific questions ever asked. Are we alone in the universe? This is the story of Viking, one of the most ambitious robotic missions ever built. The Viking program was originally planned as a continuation of the Voyager Mars concept, not to be confused with the later Voyager probes sent to the outer planets. NASA intended to place 2 orbiters around Mars and 2 sophisticated landers on its surface. The project was enormously expensive. Viking 1 and Viking 2 together cost approximately $1 billion in money of the time. More than half of that amount went into development of the landers. Adjusted for inflation, Viking remains one of the most expensive robotic planetary programs ever undertaken, comparable to several $1 billion today. This tells us something important about NASA's priorities. Although the Apollo program was ending and NASA's overall budget was falling from its 1960s peak, Viking was not a small side project. It was a flagship mission. NASA was willing to invest heavily because Mars represented one of the greatest scientific questions imaginable. Could life exist beyond Earth? Each Viking spacecraft consisted of 2 major parts: an orbiter that would remain above Mars, and a lander that would separate and descend to the surface. The orbiters would photograph potential landing sites, study the atmosphere, and relay signals between Earth and the landers. The landers carried cameras, meteorological instruments, chemical laboratories, and free biological experiments designed to search for signs of microbial activity in the soil. Nothing this sophisticated had ever been sent to another planet. Viking 1 launched on August 20, 1975. Viking 2 followed on September 9. After traveling for almost a year, Viking 1 entered Mars orbit in June 1976. NASA had originally hoped to land on July 4th, the bicentennial of the United States. But orbital photographs showed that the planned landing site was more dangerous than expected. NASA delayed the landing and searched for a safer location. The new target was Krysa Planitia, the Plain of Gold. On July 20, 1976, exactly 7 years after Apollo 11, Viking 1 began its descent. This was the moment when Mars exploration changed forever. Landing on Mars is incredibly difficult. Engineers sometimes call it the Mars problem. Mars has an atmosphere which creates intense heat during entry. But the atmosphere is much thinner than Earth's. That means it is thick enough to cause dangerous heating, but too thin to slow a heavy spacecraft completely with parachutes alone. A Mars lander must lose thousands of kilometers per hour of velocity within only a few minutes. And it must do so autonomously. Depending on the position of Earth and Mars, radio signals can take roughly 4 to more than 20 minutes to travel one way. Mission Control cannot manually fly the landing in real time. By the time engineers on Earth receive the signal that atmospheric entry has begun, the spacecraft may already be safely on the surface or destroyed. This is why the landing sequence is sometimes called the 7 minutes of terror. For Viking, the lander entered the atmosphere protected by a heat shield. Atmospheric friction slowed the spacecraft and heated the shield to extreme temperatures. A supersonic parachute then deployed. The heat shield was released. Radar measured the distance and velocity relative to the ground. Finally, retro rockets fired. Viking descended slowly and landed on 3 legs. Every stage had to work perfectly. There was no possibility of a second attempt. At 11:53 UTC on July 20, 1976, Viking 1 landed safely. Shortly afterward, it transmitted the first clear image from the surface. The initial picture showed one of the lander's footpads resting on Martian soil. Then came the panoramas: rocks, dust, a distant horizon, a pale red sky. For the first time, humanity was looking across the landscape of Mars from the surface itself. Viking 1 was designed to operate for approximately 90 days. Instead, the lander continued transmitting for more than 6 years. Its final communication came in November 1982. Viking 2 landed in Utopia Planitia on September 3, 1976. It operated until 1980. Together, the two orbiters and two landers produced an extraordinary scientific record. They photographed the landscape, measured temperatures and winds, observed seasonal changes, analyzed the atmosphere, studied the chemistry of the soil, and searched for life. Viking carried 3 biological experiments. The most famous was the labeled release experiment. It added a nutrient solution containing radioactive carbon to a sample of Martian soil. If microorganisms consumed the nutrients, the experiment expected them to release radioactive gases. When the nutrients were added, the experiment detected gas. For a moment, the result looked like evidence of biological activity. But the other experiments did not provide the expected confirmation. Most importantly, Viking's gas spectrometer did not detect significant organic molecules in the soil. NASA therefore concluded that the positive signal was most likely caused by unusual non-biological soil chemistry. The official interpretation was that Viking had not found convincing evidence of life. But the debate never completely disappeared. Gilbert Levin, one of the scientists responsible for the labeled release experiment, argued for the rest of his life that Viking may actually have detected microbial activity. Later Mars missions discovered perchlorate salts in the soil. When heated, perchlorates can destroy organic molecules and produce chemical reactions that complicate the interpretation of Viking's results. Some researchers therefore argue that Viking's instruments may have been unable to recognize the evidence they encountered. However, no scientific consensus exists that Viking discovered life. The careful conclusion remains: Viking produced intriguing and sometimes ambiguous results, but it did not provide definitive proof of Martian life. Viking also created one of the most famous Mars mysteries. On July 25, 1976, the Viking 1 orbiter photographed a region called Cydonia. One image showed a rocky hill that appeared to have eyes, a nose and a mouth. It looked like an enormous human face staring into space. The feature became known as the face on Mars. NASA scientists immediately explained that it was probably a natural hill combined with shadows, low resolution and the angle of the sun. But the image captured the public imagination. Books and television programs claimed it might be a monument built by an ancient Martian civilization. Some people believed nearby hills were pyramids or ruined cities. For more than 20 years, the original Viking image remained the center of speculation. Then, in April 1998, NASA's Mars Global Surveyor photographed the same feature at much higher resolution. There was no carved face. It was an ordinary eroded mesa. Later images taken under different lighting conditions made the explanation even clearer. The face on Mars was a powerful example of pareidolia, our brain's tendency to recognize familiar shapes, especially faces, in random objects. So the face on Mars was discovered by Viking 1, but it was Mars Global Surveyor that finally provided the decisive high-resolution images. The early Mariner images did destroy the old idea of intelligent Martians, cities and artificial canals. But it would be misleading to say that the proved Mars had always been dead. Mariner 9 discovered valleys and channels suggesting ancient flowing water. Viking showed that Mars was chemically complex. Later missions found minerals that form in water. They discovered ancient lake beds, river deltas, clay minerals, sedimentary rocks, organic molecules, and large deposits of water ice. Today, scientists believe early Mars was much warmer and wetter than it is now. Billions of years ago, it had rivers, lakes, and possibly even an ocean. The question is therefore no longer, are there intelligent beings building cities on Mars? The question is, did microbial life ever begin there? And could primitive life still survive on the ground, protected from radiation and extreme surface conditions? Viking transformed Mars from a distant mystery into a world we could finally begin to understand. It gave us our first panoramic views from the surface, our first long-term weather station on another planet, and one of the greatest scientific mysteries that remains unsolved to this day. But after Viking, something unexpected happened. For nearly 2 decades, humanity almost stopped exploring Mars. Many believe the great era of Mars exploration was over. They couldn't have been more wrong. Because a tiny rover, no bigger than a microwave oven, was about to reignite humanity's passion for the red planet and eventually pave the way for curiosity, perseverance, and perhaps one day the first humans. Join me in part 3 as we explore the incredible journey from Pathfinder to Starship and humanity's boldest dream yet, building a city on Mars.